In this video, we will perform teledeogram and simulation examples. The tab on the left is where we start the simulation and perform tests. First, let's take one digital input and one digital output to the editor screen and establish the connection between the two blocks. When we come to the simulation section and click Start, as you can see, there is an input-output area. When we click Start, we see a button related to the digital input and an LED related to the digital output. When we click the button, i.e., check the box, we see the LED lights up, and when we uncheck the box, the LED goes out. This is the 1 to 0 situation. For example, while online monitoring is active, when we want to add a new block in the gate editor, it displays an error stating simulation is running. That is, we cannot add a new block. We must stop the simulation. This same process also applies to online monitoring. I'm taking two binary registers on the screen. The reason I'm taking the registers is that I can enter a value virtually, not physically with a button. An OR gate activates the digital output if either of the two inputs is 1. Again, when I click on the digital input, it will be 1, as you can see. In the binary register, we can right-click and assign a value. If we had used a word register, we could write up to 65,000 integers. Or we could have used an analog or long register. Let's take an analog input in the editor screen to demonstrate examples related to decimal expressions. We will connect the output of the analog input to a point calibrator. Let's perform a simple calibration process. For example, 0 and 20 milliamperes. Let's say the first point is 0, the second point is 100. Let's calibrate this range. And let's observe this in the simulation. Again, when we say start the simulation direction, there's a box representing the analog output. Let's increase it slowly. With each increase, the output of our calibration points reflects the value on the screen by performing the calibration process. If it's a decimal expression, for instance, 18.7. When we write this, let's do another application. In our application, we will activate a digital input with a digital output, and our digital output will remain active for 3 seconds and then return to the basic state. The other will be an application like a ceiling circuit. For this, I added a digital input, a pulse relay, and a delay block on the screen. The purpose of the delay block is to provide a delay for 3 seconds, and the pulse relay is necessary for the set-reset circuit. For opening and closing, we connected the output to If we choose 3000 milliseconds or seconds, we need about 3 seconds. And after operating for 3 seconds, it will set the reset input. Let's do the simulation. When we say start, there is a feedback error on the screen. If a block re-enters the circuit from its own system, there is a need for a loop, a cycle, a delay in between. We need to throw a flag in between to provide these delays. It might be a 3-second delay, or there might be no delay. If a block reintegrates into its circuit system, such a feedback error occurs. After adding the flag, we can start the simulation. Let's try. I pressed, released, activated digital input 1. 3 seconds later, I saw the digital output light up and go out after 3 seconds.